today we're going to do the last section in our inequalities unit. It's lesson 10.8, graphing systems of linear inequalities. Remember, we did graphing systems when we did our systems unit in unit 9. So you're going to see a lot of similarities to that. Today, though, we're going to be actually shading areas of the coordinate plane that make the solutions true. So we're going to start out with reviewing a little bit. Our objective: to graph the solution set of a system of two linear inequalities and two variables. Review. Number 1. It says graph the following system of linear equations and the linear inequality. Okay, so number 1 obviously is a system of linear equations. We have 2x minus y equals 8. We need to put that into slope-intercept form. So I'm going to subtract 2x, and when I do, I get negative y equals negative 2x plus 8. I'm going to divide by negative 1, and I'm going to get y equals 2x minus 8. So I have a slope of 2, and I have a y-intercept of negative 8. My second equation, I'm going to subtract x so that I get y equals negative x plus 1. My slope is negative 1 and my intercept is 1. Okay, I'll graph the green one first since I already have that pen going. So at the origin, I go up 1. From there, my slope is down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Okay. Now let's go to the purple, and we have an intercept of negative 8, so that looks like it's 10, so we're right there. And then on that one, we have a slope of 2. Okay, slope of 2 means up 2 over 1, up 2 over 1, up 2 over 1. Oh, good, we found where they're going to overlap. And remember, where those points intersect was the solution to a system of equations. Remember, an equation, it'll have either one solution, infinite solution, or no solution. And in this case, we get one solution. Okay. And that point of intersection looks like it is 1, 2, 3, negative 2. So that would have been our solution. Okay, so in the last section, you graphed linear inequalities. This is already in slope-intercept form. Number 2, y is greater than negative 8x plus 4. We're going to do a dotted line since it just is a greater than. My slope is going to be negative 8 over 1, and my intercept is 4. Okay, so from the origin, I'm going to go up 4, 1, 2, 3, 4. From there, I'm going to go down 8 and over 1. I'm going to draw my dotted line. Let's move that a little bit. Oh gosh, that's not even on. Okay, so I have my dotted line, which means that the points on the line are not solutions, and I want to go greater than. So if I pick a point, I know that my y values are getting larger as I go up, so I'm going to be shading everything basically to the right of that dotted line. Okay, so now we're going to take and apply our lesson 10.7, which was graphing linear inequalities, with our graphing of systems of linear equations, and we're going to be we'll be putting a system on, and then we will solve it and find out where they overlap. Okay, so let's look here and see what we got. Says steps for graphing systems of inequalities. Graph each inequality on the same coordinate plane. Remember, if an inequality has a less than or equal or greater than or equal, it's a solid line, and those points are included in the solution. If the inequality has less than or greater than, it's a dashed line, and those points are not included as solutions. Once you find the solution to each inequality, you shade the correct half plane. If y is greater than or equal to, we'll shade above. If it's less than or equal to, we'll shade below. The solution to the system of linear inequalities is the intersection of each half plane. All right, so in the first example, we have y is less than or equal to 3x minus 6. We know that it's already in slope-intercept form, so slope is 3 over 1, intercept is -6, and this is going to be a solid line. Okay, so from the origin, I go down 1, 2, 3, 4, 5, 6. I put a point. Then from there, I go up 1, 2, 3 over 1. 1, 2, 3 over 1. This is a solid line. I don't have to really graph both of my inequalities before I draw my lines because we're really not concerned of a point of intersection. We're going to be shading a whole area. So it's a little bit different. Okay, so this is less than. So if I'm touching a point on my line, I know that the y values get smaller as they go down. And I forgot to tell you, you may want to pause the video because you're going to have two colors that are going to be overlapping. So if you have a pencil and possibly a pen or a colored pencil, two different things, so you can tell where they overlap. This highlighter makes it really nice because in a moment you'll see where they overlap, the color changes, but that might not be as easy for you all to do. Okay, so y is greater than -3/4 x plus 3. That's also in slope-intercept form. My slope is -3/4. My intercept is 3. And this is going to be a dotted line because it's greater than. I find 3 on my y-axis. It's my y-intercept. And from there, I'm going down 3, 1, 2, 3, 4, and over 4. I'm going up 3 and left 4. I take and I draw my dotted line through these points. And when I do, I now look and I think, where are they greater? Well, if I touch this point right here on the y-axis, I know they're getting greater as they go up. So I'm going to be shading, I guess you could say, above this line. And remember that the points on the line are not included as solutions because it's a dotted line. Where you see that orange is those are solutions. So if I asked you to name one solution for this system of inequalities, I could name this point right here because it's in orange. So that's 1, 2, 3, 4, 5. That's 6, 0. If I said to name something that's not a solution, well, 0, 0 is not shaded at all, but it could also be something you choose in the pink or the yellow. But I'm just going to choose 0, 0. So everything that is overlapped is a solution. Okay, let's go ahead and do some practice. In number 1, we have y is greater than or equal to -x plus 2. That is in slope-intercept form. So that means that my slope is -1 over 1, and my intercept is 2. My line is solid. When I graph this, I'm going to go up 2 from the origin, and then I'm going down 1, right 1, down 1, right 1. I can also go up 1, left 1. When I do that, I'm going to make my solid line. And make your line go all the way through the coordinate plane. Don't let it stop so that you can really see the shading because there's obviously infinite solutions, but it's good to see all of them on there. It says where the values are greater. If I put my pen on one of the points, I know that y's values are getting bigger as I go up. So I'm going to shade this. And remember that it's solid, so the solutions, the points on the line are also solutions. All right, and number 2, we got to do a little work to get it in slope, not number 2, but the second inequality, we've got to do a little work to get it in slope-intercept form, so that we're going to subtract -2x, and we get y is less than -2x plus 4. I'm going to divide by 4, and when I do, I get y is less than -1/2 x plus 1. My slope is -1. My intercept is 1. So I'm going to do this in green. This time I'm going to 1. And then from there I'm going down 1, right 2, up 1, left 2, and this is going to be a dotted line because it's less than. All right, so let's see what we got going here. I'll make it hit a little bit better. dotted line. That means points are not included on this one. And then it says less than. So if I'm touching a point, I know if I go down, those are the values that are going to be less than. And there's not much orange overlapping on our coordinate plane. Obviously, this is going on and on, so there's a lot of infinite solutions, but you see my orange is just in that section. Again, let's try to pick a point. Let's pick this point right here. Well, I did it. Let's do it in red. Right there. So that means I'm going over to the right 1, 2, 3, 4, 5, 6, 7, and I'm going down 1, 2, 3, 4, it looks like. So a solution would be 7, -4. Not a solution, of course, is the origin. So 0, 0. Okay, let's see how many more I have here. Oh, we got quite a few. Okay, so I will do, let's get this bigger so I can see what I got going. I'm going to try to do 2 and 3 with you before the time goes out, and then I want you to do a couple on your own as well. So the next one, we have y is greater than 1. So if I think about that as an equation, that's y equals 1, and y equals 1 is going to be a horizontal line through 1. And remember that this is going to be dotted. So I'm going to dot right through 1. And shading, greater, well, greater is going to be above. I'll just use pink for that. Greater is above. And then let's look at x is less than or equal to 3. If I think about that as just x equals 3, I'm going to be making a vertical line through 3, and this is going to be solid. And this says less than or equal to. Well, where are the points getting smaller? To the right or to the left? Definitely to the left. They're getting smaller. All right, so I'm going to go ahead and I'm going to shade. I'm going to shade all of this. And again, where mine overlaps in orange is where the solutions are. So let's look at this. If I wanted to name a solution, I could say on the y-axis right there, I could say 0, 2. If I wanted to name a point that's not, obviously, again, the origin is not a solution. Just so you're familiar with those. Okay, we're going to try to do one more together. We have about 2 minutes before it times out. We'll see if I can get there. To get x minus y is greater than 2 into slope-intercept form, I'm going to subtract x, and I'm going to get y is greater than negative x plus 2. Then I'm going to divide by -1. What happens when I divide by a negative? I switch that inequality. And when I switch that inequality, I get my slope, it becomes less than. So my slope is 1 over 1. My intercept is -2, and it's going to be dotted. All right, so let's go down to -2. And then from there, I'm going up 1 over 1, up 1 over 1, down 1, left 1, and this is a dotted line. Okay. Less than means that my points are getting smaller below the line. I'm going to color all this in. Oh gosh, I have about 30 seconds. Let's see if I can get the other one. If not, we'll come back on and finish it. Okay, so I'm going to subtract x, and 2y is greater than or equal to -x plus 1. Okay, rather than rush this, go ahead and graph that second inequality on there and do your shading. And then I also want you to do 4 and 5, and when we get back on, we'll go over those together. I'll see you in a few minutes.